Hi, behind me is one of the world's most, is it the world's most, yeah, world's most expensive, I'll go with that. People love that. Yeah.
This is the world's most expensive Sims younger brother.
Younger brother. Hi, behind me is the younger brother of the world's most expensive do-it-yourself full motion flight simulator, and I've done another video on that linked in down below. I've also done a full tour of the previous one, so this is an upgrade to the previous one, and I've done a video on all the hardware and software solution that drives and interfaces all this. But this video will be going inside and under and taking a look at this full original 747 cockpit, and it cost a lot of time and money here in Sydney to get this from the US here in Sydney, so let's check it out. And I'm here with Rod Redwin, who is the designer of the from Simulator Solutions, who is the designer of all the hardware and software which we've done in the previous video. So Rod, tell us about this frame, although we did in the previous video, but let's walk around and have a look at this original 747 cockpit. It doesn't look original at the moment.
It is original. Some of the cool things you can see about it, if you start to have a look here, you can get an idea of how thick the skin of the aircraft is. So it's about 3 or 4 mil thick.
Yep.
In places. It gets even thicker where there's doublers, and a little bit thinner in other places. Doublers is where there's 2 layers of skin,
right?
Or there's a layer of skin and there's a rib or a stringer or something underneath it.
Why would they have 2 layers of skin?
In areas where they join the skin together, you often, in some places, you'll double it over, which saves on seams. In other places, they're butt jointed and also filled with a silicon-like compound as well.
I like your trolley here for all your wiring.
Absolutely.
Doing a system like this and all your connectors, that's vital.
And the ever wonderful PET braid that we use as well
right.
down there. It's fantastic for keeping wire bundles together.
All right. So this is a 747 400 cockpit.
So the keen eyes will see the Star Alliance logo still stuck on the side there.
Still on there.
United Airlines are a proud member of the Star Alliance, clearly.
Fantastic. So this came from the boneyard, did it?
Yeah, this came from one of the dismantlers in Tupelo, Mississippi.
Right.
There's a number of dismantlers that operate around the world. In Tupelo, Mississippi, over on the West Coast. In California, also plenty of dismantlers in other places around the world. Big one in the Cotswolds Airport in the UK as well.
And you don't have to be somebody to get one of these. You can just contact them and go, hey, I want a 747 cockpit, and I'll sell it to you.
You can. It depends upon who they are. There's certainly no regulations, right. But there are unfortunately a lot of tyre kickers around, and yes. who waste a lot of time saying, oh yeah, I want a cockpit. And they'll come back and say, yeah, it'll cost you 30 grand. I still want a cockpit. Okay, send us a deposit, and they disappear.
Yep.
So also the logistics involved. They're aircraft dismantlers. For them, an airframe is money. Mm-hmm. It's cheaper for them to cut this up using a giant claw on an excavator than it is to cut a cockpit off and try and sell it, especially if somebody's going to muck them around and take a lot of time to get it. How do they get it off? What condition does it have to be in? How many specific parts do you want to keep on it? It's quite a complex operation.
So do they buy the whole aircraft from the airline, or do the airlines just sort of park it there, and if they're able to sell...
No, they actually, they will buy the entire hulk from the airline,
right.
Whether it comes with or without engines and certain rotable spares. Mm-hmm. And I should mention while I'm here what a rotable spare is. So rotable spares are very popular in the aviation industry. A part rolls off the manufacturing line, or take a chair, that's a seat, in a cockpit, that's a good example. So the seat rolls out of the Arpeco manufacturing line with a serial number. Now that seat could be fitted to a 747 with United Airlines, and after X number of years the seat is pulled out, it's sent off to be reconditioned. It still has the same part number, and that part might end up with KLM. Or it might end up with a different airline, might end up with Qantas. And so these parts, these rotable spares, they can be zero-timed many times in their life, they still have the common serial number, and you can trace every single thing that has happened to each one of these items. Every modification that's been made, every time it was installed, every time it was removed.
Is that a public database? Or?
No, not at all.
I wouldn't think so.
And in the old days, and probably still the case with a lot of the parts, when you buy a roadable spare, they actually come with a wad of 1-inch thick paperwork which lists every single person that's done anything to this throughout the part's entire history.
So if somebody's repaired it,
somebody's repaired it, what the repair was, what the fault was, and that's one of the reasons why some of these parts are so expensive, is because the amount of paperwork and the systems and the traceability that you need. Because if, unfortunately, an aircraft's involved in an accident, people want to make sure that all of the parts in that aircraft were genuine, and were all working correctly and had been repaired correctly.
Wow, so that's why in crash investigations can probably take years just going
Absolutely, absolutely. Yeah, there's huge amounts of paperwork to go through, records that are kept for airframes, records that are kept for engines, all sorts of different logbooks, and then you start to get into the individual parts, and all of the parts have different manuals that apply to them which tell you how to tear the item down, what components you need to use with them, what testing values, you know, if you're testing a circuit, they even tell you how many ohms of resistance the circuit should have, and what the rejection rate is. The crimping tools we have, they have a go/no-go tool, where you squeeze the crimping tool together. If the go tool fits in, you're good. If the no-go tool fits in, you're no good. You can't go with it. So the level of detail is astonishing. But for us, we're heathens, and we don't respect a lot of that sort of stuff.
By us, you mean the simulator enthusiast?
The simulator enthusiast, absolutely.
All right, can we have a look at the front? Because this is an airframe. This is the actual look. You can see it's cut out here. Here we go. I'll turn my light on. There we go. So this is an actual, you can see this actually comes from the actual 747.
Absolutely. So what you can see here is you can actually see the end of the co-pilot, or the first officer's rudder pedals, which is in this little box here with the carpet on the front of it. So that's behind there is the first officer's rudder pedals. You can see some cooling ducts, you can see some cooling manifolds, and then you can also start to see a whole stack of wiring in there, which is part of the SimStack stuff. And which is just up there.
Oh yeah, there's more boards up there.
More boards hidden up there, more SimStack boards, power supplies, distribution boards, Ethernet switches, all sorts of wonderful stuff up in there.
Yep. Oh, you've installed DIN rails in there, so
absolutely.
You can put your boards on. Nice.
Makes life very, very easy. Clip them on, clip them off.
And there's an Ethernet switch.
Absolutely.
Something you won't find in a regular 747.
You'll actually find Ethernet switches in modern aeroplanes as well.
Oh, you will?
Yes, a lot of the aircraft use different types of Ethernet buses. So yeah, it's quite surprising.
So what is this cooling system for? What are these cooling pipes here? What are these for?
In the original aircraft, this is the original aircraft, all of these pipes were used to either push cooled air into the cockpit, or to remove hot air from the cockpit. So yes, the aircraft are pressurised, but they still need big recirculation fans to move this huge body of air in and around the aircraft. And as you will see when you get inside, these old-fashioned incandescent bulbs can actually get quite some serious heat to them. Nice.
So what is this assembly here that looks like steering on the front?
This assembly here is actually the rudder pedal system.
Yep.
And there's two of these, there's one on each side. This one has had some modifications. This plate's not original, which is and this additional plate is used for a centering and trim mechanism. In the real aircraft, there are cables that mount onto here, and these cables run off to the various control systems and linkages within the aircraft.
Because the 747 is still fly by cable. You can, even if all the avionics fail, you can still land that puppy.
Absolutely, it's a fly-by cable. The aircraft's what we call an electromechanical beast. So, as I said, the airframe's based on the original 747, which first flew in the 60s, and over time, they've made various modifications to the systems on board. And when they removed the flight engineer, when they moved from the 747-300 to 400, a lot of those changes were to do with the electronic systems that were brought on board. So the system at the wing may still be the same, but there is a computer or some sort of electromechanical interface between the cockpit and the old systems in the aircraft.
And there's the nose. How much further would the nose extend out?
I think the nose came out another metre or so, and then you had a radome that was on the front of that.
That's just for the weather, isn't it?
That's for the weather radar behind.
It doesn't detect other aircraft.
No,
Right.
no. That's all done through the. It's now through the ADS-B system, which is where the aircraft transponders, which is where the aircraft actually talk to each other and tell each other where they are and what height they're at.
Got it. All right, let's have a look underneath.
Yeah. We can just have, if you want to have a bit of a crawl under,
Yeah.
and we can just have a look at some of the places where we'll actually go to. And
All right, we're underneath. Rod, tell us. Oh, look at that. There's a pulley up there.
There's a pulley up there for one of the old flight controls that would have
Wow.
been connected to the rudder system.
Yeah.
The wonderful silver thing that you can see there hanging down underneath the floor, the silver cylinder, that is a synchro. Synchro as opposed to a resolver. Yep. And that particular one is connected to the ailerons. So as the pilot moves the ailerons to the left and the right, that synchro will pick up the deviation left and right. There's another synchro buried up in there somewhere which is connected to the elevator, and there's another one somewhere around here which does the rudder as well.
Oh, what is that thing?
That's an elevator. I think that's the elevator centering mechanism, or it could be the aileron centering mechanism.
Right.
But it's all part of the.
You're not an aircraft mechanic.
No, I'm not an aircraft mechanic at all.
You just do simulator hardware.
Absolutely.
Yep.
And then what we've got over here
Yep.
is we've got the resolvers that are connected to the throttles. So as opposed to a synchro, which is a three-phase thing, the resolver is basically two transformers.
Yep.
And it's slightly different. Still gives a sine and a cos value, but in a different way, and of course at a different voltage.
Of course. These springs here, these springs up here look like trampoline springs.
They are trampoline springs, so they're not original. No.
Yeah. Oh,
But-
you've chopped out some cable here.
Yeah, cables have been chopped out in all sorts of places. A lot of that was actually done before the simulator arrived here.
Right.
And you can see other stuff here.
Oh, yeah.
And if you notice, everything has got all of these yellow labels on them, which tell you a lot about where the cable came from. And what that's telling us is it's connector Delta 41295 Juliet. It's wiring loom 4760. It tells us the position, and it'll also tell us some other information. You also have grounding blocks here, which is all the grounds will run into these, and they're of course riveted and attached to the fuselage and the frame as well.
So the entire frame of the aircraft is
The frame is a ground, yes.
So they don't run ground cabling?
No, everything is a common ground.
Okay.
And we've used that in the simulator as well. But in the actual aircraft, AC and DC share the same ground.
Ah, interesting. So they don't have any ground fault issues?
Well,
like star grounding issues?
Generally
things
not.
like that?
They've worked all of that out.
Yep.
But what it does lead to is if you have a chafing problem, and if you start to chafe on the wires, you can actually cause a short circuit in the aircraft as well.
That looks new.
That one is. That's new, yes. That's to damp out the control forces. So as you manipulate the controls in the cockpit here, it actually damps out the movement.
Got
And
it.
a lot of these functions are performed by the original aircraft feel unit. So you have an elevator feel unit, an aileron feel unit, which react to speed. They're connected to hydraulic systems, and it's incredibly complex stuff. And you still have cables that run the entire length of the fuselage as well.
Wow. That's impressive. All right, as you can see, it is a real 747. How much would this weigh?
I have no idea of the weight of this at the moment, but it's not insubstantial.
No.
And you can see the lovely green colour that everything is, which is primer green.
Primer green. Fantastic. All right, shall we go check out inside?
Absolutely.
Let's go. So that's the rudder.
That's the rudder moving.
Yep.
And you'll see that it's actually connected to the rudder synchro, which when we connect up the rudder synchro will give us the position of the rudder pedals.
Right, so you're pushing on that now.
I'm pushing on that now.
and that will translate to the cockpit.
Absolutely.
Yep.
And it'll translate to the flight controls in the simulator software.
Is there anything on this that you haven't, that you go, oh, we just won't bother hooking that up? Or do you guys, is 100% realism? Every single, this project's not done unless every single thing is...
It's a law of diminishing returns. At this stage, we can't see the point in hooking up the windshield wipers because it's never actually going to get the windshield's never actually going to get wet.
Right.
But there again, the windshield wiper motors, incredibly complex so that they can move at the right speed, so that they move into reverse, so they park and they latch in place. And it's just, as I said, the engineering that goes into some of this stuff is just truly awe-inspiring.
So you could spend like a month just getting, or weeks, just getting the wipers to simulate properly.
Mind you, I think it took us a couple of days to actually work out the wiper switches. Because again, electromechanical, there's logic in the switch which translates to logic in different relay systems. And when you're sitting there trying to work out, if I turn it into this position, now I've got nothing connected, but if I move into this position, I've got one wire grounded. And if I move to the next position, I've got 3 wires grounded, and the 4th position, nothing's grounded. Hang on, how on earth do I get this logic to work?
Wow. You can see where they've cut away. You can see that they've just got in there with a big circular saw and just cut that right off.
Yep, the angle grinder is your friend.
And somebody else probably bought the radar system.
Absolutely, that's probably still in service.
Wow, amazing. All right, let's go. Oh, what's that board up in there? I see a board up in there.
That's part of the, that's the display system.
Oh, that's it, yep.
So there's a couple of LCDs.
Computer,
No, it's just an LCD controller, which will be connected to a DVI, VGA or HDMI card.
Got it.
So I think they're LG laptop screens from memory that we've used inside that are just the right size.
All right, let's go inside. All right, we're inside the cockpit here, and this is where you really need a wide-angle lens. I do have a second little GoPro set up, but Rod, tell us all about the inside. Well, where do we start?
Yeah, absolutely. You see a lot of brown, a sea of brown.
So everything in here is original?
Everything in here is original, absolutely.
Right. To the spare, like the spare bulb panel?
To the spare bulb panel, absolutely, in the side of the cockpit, everything is original. There's a few things missing from the library, like the 3.5-inch disk drive that's still used to update the flight management computer.
Really? What, the flight management, there's a disk drive in
here? There's a disk drive in here, 3.5-inch disk drive.
No way, I didn't know. That is remarkable. Wow, so everything, everything is original. I'll show you the doors.
Yeah.
And, everything is...
And we've still got the original certificate of airworthiness on the back door as well.
Nice. There it is.
Yep.
But this is a new alloy frame on the back end.
That's correct.
So
yes.
Obviously,
the cockpit actually actually did go back further.
Right.
And we've shortened it for various reasons. And what you see there is the escape hatch.
That's the escape hatch.
Absolutely.
Wow. And is there a ladder to get you down?
No.
747 is
it's a long way up.
It's a long way up.
There's actually a series of descenders. There's 4 what they call descenders, which are steel cables attached to a braking mechanism.
Right.
So the idea is you grab that from above the aircraft library and you climb up on the seat and you dive out the hatch and you use these descenders to gently lower you to the ground.
Oh, that's terrific.
I have heard from 747 pilots that have said, nope, I'm going down with the ship rather than jump out of that hatch over the head.
I'm sure if push came to shove, they wouldn't.
And they might need to be shoved out of there as well. Absolutely.
All right. So as opposed to the old simulator that we looked at, which was just a combination of a few like original panels and things.
Yep. So the keen-eyed would notice that there's a difference with the throttles here. You've got different colours on them. They're a slightly different shape, and the speed brake handle is slightly different. So the speed brake handle is this one just there. So that's some of the differences. We have the genuine trim gauges, which I think we might take back to the lab and tear one of those down because they're pretty fascinating what's inside of those.
Fantastic. That could be coming up in the following months. So.
The multifunction control display units, MCDU, multifunction, Multifunction control display units, MCDUs here. These are the genuine units, but we have installed a colour LCD display behind there, and we have actually gutted the units, and we use a SimStack board to connect to the keyboard matrix and also the various lights that will turn on at different stages depending upon what the aircraft is doing. Other cool little things, the transponder here operates at 115 volts, 400 hertz. The weather radar, would you believe, is ARINC 429. All it is a couple of pots, some switches, literally pots and switches, yet it's got a whole series of ARINC 429 cards in there to allow you to control the left and right hand systems independently. And it goes off and talks to all sorts of computers buried deep within the aircraft to control the displays and show you the weather radar.
Neat. Now the screens aren't hooked up yet?
The screens aren't hooked up yet. These are another area where we've not used the original components. So these are just LCD displays of varying sizes, sourced off some of the online websites that people might know of. And that's mainly because the original displays are 8-inch square displays.
Right.
You try and find an 8-inch square LCD panel.
That's going to be hard.
That's very, very difficult. The original display units themselves, the screens, this particular aircraft had CRT displays in it. You can use them, but you have to install an ARINC symbol generator and a whole series of extra stuff to go with that. Again, you've also got to have 115 volts, 400 hertz, and we're talking some serious current that those things would require as well. So for ease of assembly and time, we've actually gone for the screens that we put in here. And once you get up and flying, you really can't tell the difference.
So will they be a square 8x8
yes,
form factor display?
we have some external bezels that will go on those, and it'll make it look pretty authentic. Yeah.
So what simulator software does this tie into?
So this simulator is using Aerowink's PS10 or Precision Simulator 10, PSX as it's sometimes known by, which is written by the Aerowinks company based out of Germany. One guy has written this piece of software.
Wow.
He's been writing the software now for over 20 years. Jeez. He started with version 1 and then jumped to version 10.
Oh, okay.
And when I say it simulates 99.9% of the systems on board, it even simulates the circuit breakers on the panel buried down there.
Wow. Yep. And I think you were talking to me before this, how you've got him to add some stuff, is that right?
Oh, absolutely. We found things that we thought that were there and they weren't there, and we've required additional pieces of information, and he's come back to us and said, I always built this software so that it could be used in a simulator, but you guys have just gone to a crazy extreme.
So he just envisioned like people at home with a sort of like a garage.
No, he's actually been out here and he's seen the original sim, and he knows a number of the members of the community that are building these aircraft, these 747 sims. So he always knew it was going to be a very, very complex simulator, but when we've started to come to him with some even more diverse and interesting requests, he's turned around and thought, oh, okay, yeah, I can do that. I can send you the variable. And, you know, we've also had animated discussions with him and many other members of the community, some of whom are engineers, about how systems work. And we have discovered so many differences between aircraft variants, different line numbers off the production line, different airline options. It's absolutely astonishing.
So just one plane, like different planes from the same
airline.
Like Qantas, two 747s, they could be have
absolutely
like significant differences.
Not significant differences, but differences in aircraft logic.
Enough that you'd need to know about.
Absolutely. Not so much the pilot, but more from an engineer's perspective.
Okay.
And when you're trying to build a simulator as real as you can get it, you start to come across these things, and you think, oh, hang on a sec, why is that? Does that work? Yeah. So there's some really interesting stuff that we've discovered. And we've had some really interesting debates, and we've crawled around underneath, we've looked at wiring diagrams, and yeah, it's been an interesting experience.
So it's a 20-year effort, really?
Absolutely, yes.
And it just does 747?
Just does the 747-400.
Is anyone else doing specialising in other
aircraft? There are other simulator systems for different aircraft. So the 737 and the A320 are serviced by ProSim. and they're plugins to actually Lockheed Martin's Prepared, which is what Flight Simulator used to be.
Got it.
And they're an add-on, and they don't simulate as much, and they're not as detailed, but you can still build a pretty cool cockpit with those.
Right.
And one of the things that PS10 allows us to do is it allows us to do soft dimming of all of the light circuits that we have.
And that wouldn't be in a normal...
No.
No, so they're just full-on blaring?
Yeah, most of the time they're full-on blaring, or you have to wire the lights through a rheostat or relay system.
Got it.
So whereas what we do with the overhead lights up here is we look for the position of that pot, and we feed that pot position back to the PS10 simulator software. The PS10 simulator software then tells us what brightness level each and every one of these overhead panels should be set to. So all we need to do is look at one brightness or we need to look at the brightness variable for each panel, and then we just set that variable. So when you turn the aircraft off, the lights go off. When you have certain systems turned on, the lights come on at 50%. When there's a failure of a certain circuit, or if you pull a circuit breaker, the software takes care of all of those eventualities for us.
Nice.
Because some of these systems and buses are incredibly complex, especially when you get down to some of the lower level DC buses that are powered by 2 alternate AC buses, and there's inverters and there's rectifiers and there's all sorts of crazy stuff around these simulators.
So in a way, this is kind of an improvement on the real 747.
Absolutely, yeah. Yeah, absolutely.
Brilliant. And you were telling me that one of the reasons to get this as an upgrade is because these are just aircraft nerds and they want the feel of the real switches.
Well, Dave,
and the look of the real light bulbs instead of LEDs behind there.
Absolutely. Dave, I think you played around with some of the switches in the old sim, and you've touched some of the switches in the new sim.
Yep, they're gorgeous.
It's just chalk and cheese. Yep. It's the action of these corries is quite astonishing. And
what's that? Corries?
They're a corrie, is the name of the manufacturer that makes these switches. They're a corrie switch. And if you have a look closely and you zoom into one of these, you'll notice that there's actually a shutter in there.
Oh, right. Oh, yes.
So there's a shutter that closes as you pull
it. On.
It says on, and then there's a light underneath here that says off. And so we turn that back on again, and the light turns out.
Fantastic. The other one had LED displays on
Absolutely.
it for the altitude and the heading.
These are absolutely, they're just astonishing.
Oh, look at the velocity on that.
Yep, as they bounce around backwards and forwards.
Oh, that's gorgeous.
Absolutely fantastic. And
look at it. Oh.
we can make them appear, we can make them disappear, turn it into mark. If we were in cruise, it would go into decimal mark mode.
So you drive those with a PWM or something?
No, actually, we talk to this using 3, 4, 5 independent ARINC buses.
Oh, okay, so that
whole panel is ARINC. Yep.
Okay.
So I think there's 3 FCC and 2 TCC buses. We actually parallel the 3 and the 2 buses, so there's only 2 physical ARINC devices talking to it.
Yep.
But that's how we make that work.
So what's not ARINC in here? What about these panels up here?
These panels are all wired up individually.
All individual ones go back into your boards.
Into our boards, and what we'll do is we'll pop one of these panels out,
please.
and we can have a look at the exciting stuff. So these connectors here are deuce fasteners.
Don't turn it on, take it apart, as we say on the EEVblog.
DZUS, deuce, and they interface to a deuce rail. So here we have the panel coming out with the absolutely beautiful wiring that we've put back in there. As you can see, we've reused the labels and the lovely Canon connectors. I can even get these ones off.
So you had to re-terminate those?
Yep, so we had to de-pin the existing connectors, and then we had to work out which pins we needed to use, re-pin them all with the wires. But before we did that, we also did continuity testing within the back of the panels, because the wiring diagrams vary between aircraft and fleets and panel numbers, and the panels that are in here were not the same panels that came out of the aircraft when it was retired.
Oh, they weren't?
So they have been independently sourced, And
so what, it was blank? You got it
it
as a
was
blank
absolutely
chassis?
blank
So
chassis.
they stripped it.
They stripped it.
Seats
were out. The
got it.
yeah. So
Right,
all
so
of
it's
these
just
parts
the
had to be.
frame and the pulleys underneath and a
Yep.
few other
Yep.
things. But even the
Yeah.
seats were gone.
Seats were gone. The throttles were still here, but the pedestal was empty.
Yep.
All these bays were empty. This was empty.
Right.
Tyre overhead was empty. The circuit breakers were still there, fortunately.
Right. Okay.
Yeah. And what I'll actually get you to do, Dave, is I'll just hand this to you.
Yep.
Tell me how warm that is.
Oh, I can. Yeah, that is warm. I can feel that. Whoa, that's hot. That's 40 degrees right there. Just that, and that's just the bowl.
That's just the bulbs.
That's just the bowl.
Yep.
Wow.
So what
Yep.
we'll do when we get, we'll give you some of these to take back to the lab, and you can pull the front fascias off and have a look at the number of backlighting bulbs in there and how these things go together.
Nice. So how long would it have taken you just to do that one panel, to figure it all out, to check it, to continuity test it, to figure out all the
There's
wiring,
probably-
to redo it?
And to pull the wire, or
Yep.
to create the
wire,
looms, put
create
them
the
in,
looms.
program the boards, it's probably 2 days work.
Oh, wait, that's that all?
Yeah.
Quick. You're obviously you're used to this.
Yeah, I've done a few of these.
Yeah, yeah.
Done a few of these before. And what you'll also notice is that these connectors, despite the fact that they all look identical,
Yep.
they're all keyed differently.
Oh.
So each connector will only fit into
Nice.
one specific. So that one goes into there. Where does this one go? That one goes into there, and that one goes into there.
And that's not you doing that.
That's
the
not us. That's the
747.
747.
Yep. So no one can goof it.
So no one can goof it up.
Yep.
And you know, these tell you this is J2, and you know, there's some more wonderful aircraft logic.
Yep.
Connector 1, connector 2, connector 3.
Obviously.
Obviously, yep, that's the way I count as well.
Brilliant. So because like, if a pilot just landed the 747 at an air, on a regular flight, and they indicated that that panel was out,
Yep.
they would mark that on the service log or whatever.
They
and
mark
then
that on the
before
maintenance
next
release.
flight,
Yep, some guy can come in, pull it
some
out.
person comes in, pull it in, and simply replace it. And log
Absolutely,
Yeah.
logs it. And when they
Will
replace
that
it,
log be in the aircraft here? Or?
no, those logs are all still retained by the airline.
Right.
And now's the challenge. I have to try and get this back into place.
But the pilot would have been made aware that was the next pilot that comes in. Would they have been made aware that there were changes like that? Or?
I'm just going to leave that hanging for the moment.
Rod is a pilot, by the way. He is a former flight instructor for
Yes,
light aircraft.
for light aircraft.
Yep.
The pilot can have a look on the maintenance release and see that see what's been done, see what was unserviceable, how it's been fixed, whether it has been fixed. You have minimum equipment lists in these aircraft, which will specify that certain systems can be unserviceable when the aircraft just is dispatched, and that's perfectly acceptable.
Right.
Because not everything can always be repaired at every port, and also the time and the complexity of some of these repairs. A lot of the stuff is just simply pull a box out and put a new box in, and a lot of the newer Airbuses and Boeings, they literally turn the aircraft off, turn the aircraft back on again, then if they can't clear the fault, they'll actually go and look for it. It's probably a genuine fault.
So they literally like, hello, tech support, if you try to turn it off and on again.
Now obviously turning an aircraft off and on again is not as straightforward as it may sound, and you have to make sure you don't do it when the passengers are on board, because as you know, when you're sitting there on the ground and all the lights turn off, you think, what's going to go on here?
Because the new like Airbuses, they're all fly-by-wire, and they have,
Absolutely.
I believe they even have lithium-ion battery systems, whereas this would probably have old school.
This has probably got old school NiCads in it.
Yeah, or NiCads.
I think they were
lead acid or something.
they could even be lead acids, yeah.
Yep.
But yeah, the new 787s, the new Airbuses, they've all got sort of polymer-based batteries in them, and the 787 had some big problems initially with battery fires.
Yes, it did. I remember that. Yeah, fire in the cockpits,
Yeah.
or just behind the cockpit, which was where they were.
And the simple solution was they mounted the batteries in a steel box and vented the box overboard.
I remember that. That was like 5-6 years
Yeah,
ago.
yeah, that was a great solution. It solved the problem.
Just put it in a fireproof box.
Yeah, sometimes the low-tech solutions are the best.
Right. So but they're just backup, are they? Ordinarily be or they'd be continually charged in the air via the. They tap off some of the engine power, don't they?
Oh, absolutely. The modern aircraft are far more electrical than a lot of the old aircraft were. So there's a lot more electrical systems on board and less pneumatic and hydraulic systems. Whereas the 747 has got 4 independent electrical systems or generators. plus the APU, which can't be used in flight. It's got 4 independent hydraulic systems, and because it's got 4 engines, it's got 4 independent pneumatic systems as well.
Nice.
So you've got multiple redundancy.
Yep.
But of course, all of that comes with complexity. It comes with maintenance costs. It comes with overhaul costs, and it makes for an aircraft as it gets older. It becomes very, very expensive to keep it going. And I think that's one of the things that's going to get to the A380. And they're talking about, a lot of airlines have taken the A380 out of service, and they're saying that the increased maintenance cost as the fleets get smaller will start to bite a little bit more.
They haven't been in service all that long in the scheme of things.
No, the production line's closed for the A380.
Wow.
And Singapore Airlines sent their first 2 back, and I believe they were scrapped because they couldn't find an aircraft market for them, a used market for them.
Because the market changed, didn't it? They thought, oh, bigger is going to be super
Absolutely.
huge jumbos are going to be the way to go, and then they realised, no, the more fuel efficient smaller planes were the way to do half or most of the legs out there.
And I think it also depends upon the airlines. Emirates in Dubai have got some, they own something like 150 A380s, massive numbers, but because
they've got long haul flights, just
absolutely,
like here in Australia, they're one of the main customers for long haul flights.
Into and out of into and out of Dubai. So but it's interesting. You look at the history of these aircraft and the fuel efficiency and what they've done with them over time.
Wow. Can you tell us? Oh, let's put the panel back in.
Okay, let me see if I can get the panel back in. Get it back in the right way around. And it's just a simple quarter turn on each of these, and the panel's back in.
Now tell us about some of the other very nice, cool feedback features, like the control stick, for example. You were talking about the mic, how it has, how when you are landing 747s, the feedback, the mechanical, not only the mechanical feedback, but also the sounds of
Absolutely.
levers. Can you explain
So
those?
when you touch down in the 747, there's a few things that happen. So this little pin here, that's the gear override button, that will release, which makes a funny little sound like that as it lets as the relay and the solenoid in the back of that lets go.
And the pilot would hear that.
The pilot will hear that,
twang.
and then you will hear the speed brake extend, which makes a noise. There's also a linear actuator that drives that, which we don't have installed yet, so that makes a noise. As you grab the reverse into reverse idle, there are actually some physical interlocks that some airlines have buried in the throttle pedestal, which will make a noise as they release, and not until they've released can you actually engage the reverse thrust. So idle reverse, the doors will open on the side of the engine, but it'll sit there in idle, and you can't pull thrust on the reverses until the interlocks let go. Likewise, when you stow these, you hear the noise as the mechanical interlocks kick in again. If you advance the throttles, the speed brake will retract itself. Then there's the relays that are underneath the floor in the main equipment bay, which all click and clunk.
And you can hear that the pilot can hear those.
The pilot
even
can
in
hear
flight,
all sorts of...
with all the ambient noise?
With some of the ambient noise, yeah.
Yep. Because you do simulate, when I was in the other sim, you do actually simulate the ambient noise.
Absolutely.
In the
You've
cockpit.
got to have the ambient, because these aircraft are not quiet.
Yeah.
And the 747, due to its shape, was actually a very noisy aircraft.
Oh, okay.
With with sort of supersonic flows over the windows and the top of the top of the aircraft, and so that did significantly increase the noise.
And they didn't modify that over the years because
No.
that is too significant.
Too significant a change.
Yep.
Yeah. And that leads to a lot of pilots. They'll have hearing loss in certain frequency ranges.
Oh, okay. Because a constant drone like that for
Absolutely.
12 hours a day. Yeah.
And one of the other things is there is actually a faint 400 hertz hum in here that's coming from these two units here.
Oh, why?
Because they run, for some unknown reason, at 115 volts, 400 hertz.
400 hertz.
So this device is 28 volts, yet these two things here, 115 volts, 400 hertz.
So what's humming inside? Just
It's the transformer inside.
Yep.
So the first thing they do is they take the 115 volts, step it down to 24 volts or 28 volts or something, and off they go. So
why did they have so many controls, like right next to each other with different
manufacturers?
Different manufacturers developed the
Absolutely.
different
Yep.
Right.
And as I said earlier, the great thing about aviation standards is the strange way that they're loosely applied at times.
Even with the same customer, and the planes can vary as they roll off the line.
Absolutely.
That's
And then
nuts.
some of the other cool things we've got up here is we've got the fire switches for the engines,
Yep.
which, as you can hear, they're a real positive. And then as you twist them to discharge the bottles, that makes for a very realistic feel of those units.
Because there are fire suppressant bottles, fire
Yes.
extinguisher bottles
Yes.
that pump into the engine.
There are halon bottles.
Halon bottles.
Yeah, we're horribly environmentally unfriendly,
Yes.
but not that anybody doubted that for a moment.
Well, you wouldn't care if the plane's on fire at 30,000 feet. You just,
And the
want to shut it off.
great thing about halon is it doesn't leave nasty residues in the engine core itself. So it puts the fire out and doesn't damage the engine particularly badly.
They still use those in like data centers, like your big Google data centers and stuff like that. They'll have fire, like if you're in there when that goes off, it's going to extract all the air from the...
Absolutely.
And you'll die. But what's that? Oh, smoke evac. What does that do?
The smoke evac handle. This is really, again, some of the low-tech solutions are often the best. If there's smoke in the cockpit, what the pilots would do is they would reach up and they would pull this lever down.
Yep.
What that does is opens a 2-inch diameter, give or take, hole in the top of the cockpit, in the roof of the cockpit, which causes, because the fuselage is pressurised, which causes all the air to rush up out the hole in the top of the cockpit.
Right, so they put a hole in the aircraft and it sucks it all.
Absolutely.
The pressure at 30,000, or the lack of pressure at
30,000 feet. So that's what you do. You pull the handle and it opens the hole.
Brilliant. That is absolutely so. Do any pilots turn that on just for kicks?
Well,
during flight?
there's actually a funny story with that. There was a theory, and this is only hearsay, but apparently a lot of the one of the Asian carrier aircraft 747s, the engineers kept finding matchsticks in the cockpit. What they discovered, the pilots, being a very inventive and ingenious bunch, had discovered if you just open that and stick a matchstick in there, a smidge, you can have a smoke in the cockpit.
You can have a durry in the cockpit.
And it'll go out the smoke evac handle and nobody will be any the wiser. And of course, you will notice that we still have the old-fashioned ashtrays in the side of the cockpit.
Because, you used to be able to, youngsters out there, you used to be able to smoke in aircraft.
Absolutely.
And trains and everything else.
Yeah.
That was the thing. And the non-smoking section, in quote marks, was just like literally a seat in front of the smoking section. So
absolutely.
What's going in the centre console there?
So in here we have two more screens. A screen there called the upper ICAS, and a screen here called the lower ICAS. And ICAS stands for Engine, Instrument and Crew Alerting System, which tells you about all of the systems on board the aircraft. And you've got this selector here which allows you to bring up the different screens, whether it's the engines, the fuel, the door positions, gear, and see how those systems are running. And obviously as you make changes in the overhead system, they will be replicated on the screens that you see in front of you there. And we've got the flap handle, pretty simple, set the flap positions, and we'll look at a couple of the resolvers that are used to control these. Triple redundant devices that are an absolute beautiful piece of manufacturing. The 4 throttles, the speed brakes or the spoilers as they're known, engine cut-off switches, and there's also little red lights in these as well in case you get an engine fire as well. And radio heads, we've got one of those to have a look at inside as well. All sorts of other little things. This particular panel here, the crew call panel, which is connected to the telephone system, that uses a serial, an RS-232 serial interface.
Oh, really?
Yeah.
Wow, there you go.
So all sorts of things. These particular units here, they use an SPI-like serial interface.
That would have been nice.
Where you clock the data in and clock the data out. It's absolutely fantastic if you had an engineering or an electrical diagram of it. When you have to reverse engineer that stuff, it's fun.
Can imagine.
Yep.
Wow. And what about the rudder pedals and all that sort of jazz?
The rudder pedals are still sitting down there. We're yet to physically hook the controls up to the synchro systems. And again, that's sort of one of the later jobs that we'll be doing. As we'll look at synchros, they're an absolute fantastic zero noise device. We've got these running in a couple of the other simulators, as well as the resolvers in the throttles, and the repeatability you get between sort of opening and closing the throttles. They will come back to the same 0.1 degree every single time with no noise. So as opposed to pots, which could be anywhere within the realm of 5 or 6 graduations.
Right.
So that's how they function.
So how many places did you have to source all these different modules from? I mean, did you have to, you got seats from somewhere, you got all these panels down here from somewhere?
We've got a couple of contacts who have some hangars over in the US. Aerodite Solutions is one of them, and they specialise in finding stuff.
So they're like a broker.
They're like a broker. They're good. They're in close with the disassemblers, and they go in and they'll get stuff. And you know, also they're trusted enough to be allowed to go in and get the stuff themselves.
Actually into the boneyard,
Yep.
climb up onto
Yep.
the aircraft, and actually go in.
Yeah,
And, yep.
because there again, it costs more for the wrecker to pull these parts, some of these parts out, than it does to cut them up, scrap them, melt them down, and they don't have to worry about it.
So if they've got a few approved brokers who are authorised to go into the planes, it makes their life easy, and they get money.
Absolutely, yeah. And one of the other things is many people buy cockpits. They also buy these panels, but the one thing they don't buy are the connectors.
Oh, why is that?
Because they don't think about them. And then
so
you end
buy
up
the connectors separate.
And then if you have to buy the connectors,
Yeah.
because there's so many combinations, you know, each 14-pin connector,
Oh, and the key different. as
there's
you
6
said.
different key combinations.
Oh,
So it can become quite difficult to then go and say, and you can't ringing one of these aircraft disassemblers up and say,
No,
I'd like a
they
15 SN.
yeah.
Too hard. Yeah.
Yeah.
Or $2,000 for one.
Yeah, right. And then they'll go figure
Then
it
they'll
out.
go find one for you, and then they'll probably send you the wrong one. But there
Yeah,
you go.
right.
Yeah. Some of the other little things. These things up here.
Yep.
They're the terminals for the heaters inside the windshield.
Nice.
So you can
and
see
you
the little
said
wires.
these windshields are original.
They're original, 90
had to buy those
kilos.
separate?
Came separately. Yep. 90 kilo windows. These
Wow.
ones. The side
Just
windows.
shipping those alone would have cost a fortune here.
Yeah, they did a bulk import.
Oh, okay.
A few guys got together, and I think they brought 4 or 5 of these sets of these in, side windows,
The
seats.
enthusiast community got
Absolutely,
together
yeah.
Right.
There's a warehouse a little way from here that's got a staircase in it from a 747.
Ah, wow, nice.
Some used business class seats. There's all sorts of things. There's a big market for second-hand seats as well.
What's that missing item up there? That looks like a compass.
That's the whiskey compass.
Ah, I thought it was.
Yep.
I'm right.
Yep.
That's going in there.
That's going in there.
And
We-
you'll be able. You'll drive that. You'll have
Yep, we'll use some old-fashioned technology, an air core motor to drive that.
What's an air core motor?
Air core motor is it's used in the speedo of your car, and it has a sine and a cosine coil, and a fixed, I think it's a permanent magnet, and a sine and cosine coil, and by varying the voltage that you send to each coil, you will actually set the shaft at a specific place in its 360-degree revolution.
Nice.
Problem with using a stepper motor is the stepper motor doesn't know where 0 is.
Yes.
So then
that's
you
right.
have to have
So
some sort of a
it could be
zero.
an incremental error
Yep.
as you wind it
Absolutely,
around,
yeah.
right.
So with these air core motors,
Yep.
you send it a specific sine and cosine value, and bang, it
It'll
sets
give you
it
an
to that
absolute
absolute reference every single time.
Wow.
Yeah.
So you're that fanatical about every single. So every single control in here is going back to your system and the simulator software and is going to work.
Absolutely, even the circuit breakers. Now the
Even
circuit
the circuit
breakers,
breakers.
they don't pop automatically.
Yeah.
But if you pull the circuit breaker manually, it's reflected in the software, and it will fail the appropriate system for you.
Although, when you guys are flying, can somebody outside go,
Absolutely,
I'm going to
yep.
throw them a curveball,
So,
I'm going to pop this circuit breaker and...
If you have a look at this screen here,
Yep.
and if I pull that circuit breaker, the screen goes off.
Oh, yep. It's
And if
gone.
I push that circuit breaker in about 16 seconds, give or take, the screen will actually turn back on again.
Turn on.
And that 16 seconds is the amount of time that this unit in the aircraft takes to boot.
Right. So
But-
if you're in the middle of flight and
Absolutely.
and
Yep.
bus for some reason, the pilot will try and whack that back in.
Yep. Yep. And
There it
the
is.
screen's back again.
Nice.
Now, generally the rule is you only reset a circuit breaker once,
Okay.
if you reset it at all,
Yep.
because usually it's blown for a reason.
Yes.
And
You don't
yeah.
want to take something else out. You don't
No.
want to put that short
That's
back
it.
in and take.
And the last thing you want to do is sit there and hold the circuit breaker in to stop it coming out again.
Right. Oh, so you can manually hold them in
Yep.
if you
Yep.
needed to. The co-pilot could manually.
Yeah, yeah.
hold somebody if you were so desperate.
Not recommended. Not recommended at all in any sort of circuit breaker.
Right.
Yeah.
What else are you going to install in here? Like screen? Are you going to install screens, visual screen? Like no, you've got one control screen down here, which is the simulator.
That's the software running. Yep. That's probably the only one we use. We might move, make that a bit smaller, move it down to an iPad size, so that's a little bit easier to get around. Some of the other funky things in here. This is a 10-turn pot.
Nice. At what resolution are you sampling the 10-turn pipe?
One of these, I forget which one it is. I think it's this one. We're only 1,024 steps because it's all we need.
Yep.
Only 1,024. And this one, I think we're up to 65,000.
Is that because you needed?
That's because we need that level of.
That? I can't read it.
So that's the fuel to remain.
Fuel to remain. I wouldn't have thought that would need that resolution.
Yeah, because when you're dealing with 150 tons of fuel.
Oh, okay.
And if you, because this is obviously it's more than 150 tons, but you can. The idea is when you want to dump fuel, you'll set the system in the appropriate mode, and then you'll actually dial up the amount of fuel, and it appears on one of the screens here, and you dial that amount of fuel up, and then you engage the pumps, and it will start dumping the fuel overboard. When it reaches that figure, it'll automatically shut off. And of course, guarded switches, so you can't accidentally
hit those.
Yep, and some of the other switches, these ones here, for instance, they're lock-wired shut normally.
Oh.
So it's a real conscious effort to break the lock wire, to open the guard up, to push the switch. And in those 4 cases, they are the generator drive disconnects.
Oh, okay. So you don't want to because your generators are powering everything. So only in extreme circumstances.
Absolutely.
So can the pilot cut those, or do they have like
you can pull them open.
Pull the wire.
You pull the wire, the wire will break.
Okay.
But at least you can see if the wire's been broken, and that's one of the things that depending upon how many of those wires are broken, which airline you're working for, you may not be able to depart if a lock wire is broken.
Of course.
Yep. And those generator drives can only be reset back on the ground.
Oh, okay. So so it's a single shot deal.
That's it. So when you pull that, you got to have you push that, I should say, you got to have a pretty good reason to push that.
So in theory, the pilot could disable all 4 generators.
Absolutely.
And then you've got no power left. Oh, well, you would have to deploy the auxiliary power unit, or just the battery.
Just on the battery, because the APU won't start in flight.
Because the APU is actually a little propeller that drops down, isn't it?
No, that's the RAT. That's the ram air turbine.
Oh, okay.
And the 747-400 didn't have a RAT.
Right.
The 800 does have a RAT. Now, the 747's obviously got the APU way back in the tail, which is a 5th jet engine. And that supplies air and electricity to run the aircraft whilst it's on the ground. You can take off with it still running, but you can't restart it in the air.
Got it.
So twin engine aircraft, 767, 777s, all those you can. It obviously has certain ceilings that it can operate at. But for the 747, they figured quadruple redundancy should be enough for most circumstances.
Yeah, it's never been an issue.
Yeah.
So with the twin engine ones, you would, if you had to restart them, you'd drop to the ceiling altitude.
Yeah, the systems will tell you what altitude you have to come down to start this. There's books, there's all sorts of things. This strange little black circle here is the cockpit area microphone, which is used by the cockpit voice recorder to record what goes on in the flight deck.
Yep. So that's just an omnidirectional mic.
Omnidirectional mic.
Yep.
The pilots all have a mic as well on their headsets. So the CVR's got multiple tracks, and this is one of the tracks. The headsets are obviously on other tracks as well.
So they can disable that if they want? No, they can't.
And we have some other non-standard items in here. The emergency stop buttons.
Oh yes, that's the simulator for the
motion platform. Yep. So if it goes into meltdown, we can push the button which will cause the pump to shut off.
As we saw in our previous
video on
the EV Discover channel, while we were over we were coming into New Orleans, I think. Bam!
Yeah. Yep.
The whole system just locked up. And,
absolutely crashed out on us.
And my tripods went flying.
Dave went flying. It was quite impressive.
And I put my seatbelt on after that.
Yep. And so some other, tiny quirks of this aircraft. The landing gear lever. So this entire housing actually comes out, and is about goes back to a depth of about this far.
Right.
And would you believe that the entire housing only has 1 micro switch in it originally, because the whole landing gear system is connected to a big shaft, a big wheel, and all sorts of cables, and you don't need micro switches when you got all those cables.
You don't need to sense it.
No.
Right.
But what we were able to do is we discovered that the plate that holds the 1 micro switch actually had holes drilled for another 2 micro switches. And we found the off-the-shelf component for the switches, found some screws, mounted them in, wired them up, used the same connector, off we went. And so there we go. And we talk about electromechanical.
Yeah.
I can't put the gear up because we're on the ground.
Yep.
And you know, if we're in the aircraft, after we take off, this lever, this button retracts, which will allow us to put the gear up.
Got it.
So there we go. And yep, it's a big positive action that you know that you're moving the gear.
It feels as good as it looks.
Absolutely.
Yeah.
Absolutely.
Fantastic. What are these knobs? Push to talk? Is that part of the panel over there?
Yeah, the push to talk panel, the clock button. The clock button will actually cause the clock to start. So
it all works.
Yep. Have a look at the clock. There we go. And if we stop the clock and reset the clock, stop it, reset it, start it again. Now,
absolutely brilliant.
The clock doesn't talk to anything, the clock doesn't do anything, it's just a clock.
It's an independent little thing that just
absolutely
works, that you can play with if you're bored in flight.
Absolutely, yeah. You can set the time, you can set the date, and depending upon the airline and the procedures, some airlines use those clocks to ensure that the engines have the appropriate warm-up time. If you encounter an emergency, one of the first things you do is you restart your clock. And you know, if you have a fire warning, if it's still there in 30 seconds, then you need to do something about it.
So it's a timer, basically.
Absolutely. Yeah.
Time failures and other features, you know, how long we've got to land or so. Would you do that? Maybe not.
No.
Because you've got the flight computer to do that.
Absolutely. All the information and data that's in there makes the pilot's job much easier in this day and age.
Where's the printer? Because the other one had a... Oh, no, the printer. Yeah, you're going to install the printer?
The printer is in there. At this stage, we've not installed the printer.
Is that on the cards?
Oh, look, we have it. It's sitting on the workbench.
Okay.
But there's just a lot of work. It's an ARINC 429... sorry, it's not a 429. It's an ARINC 740 protocol. And we need to develop an extra add-on board to deal with the amount of memory that it requires. Because of the way you have to send the data and the amount of data that it requires, we need an SPI memory chip, and so it's not just
I can see why that's a do later thing.
Absolutely. Yep.
Wow.
Not a simple, straightforward thing. Other cool things, this Autobrake Switch here, it's spring-loaded in a couple of positions.
Nice.
And when you're on the ground and the inertial navigation system is running, so that the aircraft knows where it is and how fast it's going, when you turn it to RTO, it will actually latch there magnetically.
Ah, brilliant. So you've got the solenoid under there?
Yep. So there's a solenoid on that latches that. Then when you take off, when the wheels lift off, it'll spring to off position. And likewise, then when you're in flight and you're coming up to where you're going to land, you think, okay, I'm going to need to set an auto brake setting. So you push it down, you turn it to the disarm position, and then you would set the amount of auto brakes you require, and again the solenoid would hold it there. As soon as you touch the brakes on the ground, it clicks off and goes into the disarm mode. So again, the mechanical spring-loaded mechanisms that go to make these things work, it's pretty cool just to sit there and play with.
I can imagine. So how long have you been working on this project? When did you start this particular one?
This particular one, I think we've been actively working on it for probably about 3 years.
3 years.
And
are you full-time at it? Or
no. This is we come in. Now this is a bit of our development platform. Right. So it was one of the first ones that we started work on. We've taken a lot of these panels back to our workshop. We've looked at the logic behind them, and you know, sort of, I was coming out here any frequency from once a week to once a month at one stage, doing a little bit of work. Obviously, Matt wanted to do a lot of work in here, so all of the panels have been reconditioned, they've been refinished, all the dents and dings and scrapes have been removed.
Matt is the owner.
Matt is the owner.
And the fanatical owner who
the
pays
fanatical
for all this
owner.
Out of his own pocket.
Yeah, and
is it a business expense? Maybe. Well, it's in his workshop here, so...
Absolutely, yeah. And so, as I said, so we've been working on it for that amount of time. A lot of the work has already been done, and we had a sort of a big spurt of work where we literally just put all the pieces together like a big Lego puzzle. And it went from nothing to having all the panels in the space of about 2 weeks.
Nice.
So I think the circuit breaker panels, which is probably one of the most useless things in the simulator, they were the first things we wired up.
Oh, right.
Actually, that panel down there was the first ones that we wired up, which, yeah, and unless the guy in the back seat gets really bored, you're not likely to use.
Got it. Are these, so these are all your cable looms up here?
The black PET braids, yes, they're all our cable looms, and they run down the side wall and to all of the SimStack boards that you saw earlier, sitting in the back corner of the simulator.
Yep.
Likewise, there's more boards out the front, and we're about to start wiring up the centre pedestal stuff, and that will go to a location under the floor, where we've got some power supplies and some DIN rails all ready to go.
And then once this, how long until this is complete, do you think, roughly, before you lift it onto the platform?
Our goal is we want this on the platform by June next year, to give us a few good months of testing and shakedown before we have World Flight in November next year. And being the 20th anniversary of World Flight, we kind of want to do something well.
Ready for that, because we just had the 19th.
Absolutely, so we want it to be pretty big.
And impress all the other nerds around.
Absolutely, we want to move. But for a while, we had the best simulator because we had the only simulator.
Some people have beaten.
Some people have beaten us a little bit, but nobody has got anything with this level of fidelity and this level of realism, especially on a motion platform, especially in the DIY zone.
Have you got plans to have you had a 747 pilot?
We've had several, and the challenge is to actually get them to come in. You know, because most of them it's their job, and they don't want to be anywhere near an aeroplane after that. But look, a lot of them have come in, and they will argue amongst themselves on how realistic it feels. Someone will say that's too loose. Some will say that's too tight. Some will say that's just perfect, and you haven't touched anything. Got it. So it's like that. It's, you know what they say about opinions.
Like this whole cockpit will be lifted like 10 metres to the... So you lift the other one off, get a big hoist and lift the other one off.
We'll lift the other one off, then we want to do some major maintenance work on the platform itself. We want to take some weight off the platform. We also want to overhaul the hydraulics because they're desperately in need of an overhaul. A lot of the fittings and things are starting to... They're starting to weep.
80s, isn't it?
Oh, absolutely. Yeah, and it's a long time. It's been running here for... Oh, it's been running here for more than 10 years.
Wow.
It was in storage for 10 years before that. So it's in need of some maintenance and some TLC, which will also let us understand quite how this is going to fit on that platform as well. Because as you saw, we've got a couple of things that poke through the floor and we can't easily chop those off, especially when one of them's the aileron sensor. That would be a real mess of that. So that'll sort of end up going on there. As I said, we're probably talking sort of June next year is when we'll get it on, and hopefully it all goes swimmingly and we've got no problems.
And you even link the rudder pedal brakes with the brake lever over here, you were saying?
Absolutely. So if I can just manoeuvre myself around here, find the right button.
Little base, it's on a... there we go. This is the actual platform. That's the... See, you can see the cog, the linear, the railings. There.
And we'll jump onto the brakes, and we'll push the brake pedals in, lift the brake lever up, let the brakes go, and they stay there.
And they stay there. Why? Because you've got a is that a mechanical?
It's a mechanical link, so it actually latches onto the braking mechanism. Now, if I push the toe brakes down again, the lever drops. And I'll let the brakes go, and theoretically, we can taxi.
Excellent.
Yeah.
That's brilliant. And I can attest it feels pretty realistic when you're in the motion simulator, but we've done I'll link in the video, I've done a whole video talking about how realistic it is in flight and feeling, and how some areas it's not so realistic as well. So.
But this one's going to be pretty awesome, I think. Once we get it finished.
How would this compare to a Boeing one, do you know? Have you been inside a real
I've been inside some real Boeing ones, and the big difference is they use a collimator display.
What's that?
A collimator display is effectively a display focused on infinity, and it uses a mirror and a rear projection system. So you'll have a rear projection screen above the cockpit, and directly in front of you, you will have a convex mylar mirror.
Oh,
and
it's a more realistic.
Yeah, and so
you'll get a depth of vision.
Yeah, it's 27 feet or something like that is the magic number. Right. And so from your eye, you focus on the mirror, which is actually a projection that's coming from above the cockpit.
Got it.
And that's why all the big sims you see have this dome out the front.
Oh yes.
And there's a vacuum in there. And that's how they get the mylar. They vacuum the mylar, which causes it to have an absolute perfect image and perfect reflection.
So it's got to maintain that vacuum during operation.
Yeah.
Wow.
Yep.
I didn't know it. That's remarkable.
And that's why you're going to pay upwards of $750,000 for a collimated display system for a modern
display system.
Just the display system.
So your display is going to stay the same for the
Yeah,
other one?
it'll be
basically just got a white plywood wall, curved wall, and then you project onto that.
We project onto that with 3 or 4 projectors. We haven't decided how many we'll use, and a computer with lots of grunt and lots of video cards, and off we go.
Brilliant.
See if we can get to 4K projectors.
Yep. And the good thing about that, instead of, because some homemade simulators will have the just LCDs in the windows, won't they? And then that's not as, like, you can't move your head and look around the pillar there, for example.
One of the big issues we do have, and a few people commented on this in the last video, is that because Prepared Flight Simulator was designed for desktop use, when you set it up in a big screen, wraparound screen like this, generally only one seat will have the correct view.
Oh,
and that will be the pilot's view. All other seats will have a parallax offset error of some description, which is why from the co-pilot seat it looks like you're about to land on the grass, but from the pilot's seat it looks like you're going to land on the runway.
Interesting, wow.
So it's all about eye position and eye height and all that sort of stuff. And there are some systems that try and overcome that and compensate that.
The professional Collimator one
it makes a big difference.
Right.
Yeah, and because your tripod was set up on the co-pilot side.
That's right. I noticed that it was kind of off at an angle, and I thought, oh, that doesn't quite line. I thought he's not lined up on that runway.
Oh, look, John will be the first to admit that he can't land, but
okay. But it looks significantly off to me, right?
Absolutely.
Got it. Wow, that is remarkable. So you pump air into here to keep it air conditioned.
Yep. So we've got some cooling systems going. I think we're going to need to up the ante on those and get some proper pressurised cooling.
One of these bulbs, if you put your finger on them, you can actually feel the heat.
Go on, Dave, do it. Go on, Dave, do it.
Each one's 8 watts, right? Each one's 8 watts. That one, Bernie, hurty. Okay, yep, that hurts. That hurts. So they get into 50 degrees and above.
Yep.
Just those.
Yep.
Each bulb is like 8 watts, right?
Yeah. I think it's something like 8 watts. Yeah.
That is. But you want the realism.
Absolutely. Yeah. Now, if you were to turn your lights down a little, and we'll see if we can get some an appreciation of the backlighting as well.
Yes. Let's turn the studio lights off here. There we go. Oh, here we go.
Now you'll have to forgive us. We've got a couple of we've got a lot of bulbs out here. So there's a bulb out in that one. We're missing a nameplate off the front of that one. But if we do some other things, we've got the master test function.
Oh, nice.
Which basically turns everything on.
And all the circuit breakers as well.
Oh, the circuit breakers are.
Sorry, they're permanently lit.
They're permanently lit, and we've got the dimming control here.
The dimming control.
Yeah.
Yep.
Which allows us to dim those and brighten those up and down.
Very nice.
Yeah.
Wow, it is, and they're bulbs under the head-in altitude and head-in display as well.
Absolutely, they're all incandescent bulbs.
Yep.
And some of the other things we can do is think, the simulator software is running. So what we've done here is we've just turned most of the power out.
Yep.
And you'll notice that the backlighting is only working in 1, 2, 3, 4 panels.
Right.
And that's the way the aircraft's designed. And the backlighting is only working at 50% brightness. So the control here does absolutely nothing to change the brightness of those panels until I start to bring the buses online. So if I bring the first bus online, you get the proper brightness. We get the 400 hertz whine going on there. And in one of the panels overhead there, you'll actually also get a split system breaker that chooses to open and close at certain times as well.
Wow.
And there we go.
That is fantastic. It really, and I can attest, even the old one, it felt like you were in the real aircraft cockpit, and it was just, this one's going to be even.
Absolutely, it's going to be fantastic. Yeah.
Wow.
Yep. So we can't wait to get it all finished and get it on the platform and go for a fly.
No worries. And you might drop by the lab one time with some synchros.
I'll
maybe.
drop by the lab with some synchros and some resolvers and a couple of ARINC components, and we can have a look at some of the guts of those and do a bit of a tear down.
Fantastic. Thanks, Rod. And I'll link down Simulator Solutions down below.
Fantastic.
Because if someone's got the money, you'll make them a simulator.
Absolutely. Planes, trains, automobiles, racing cars, you name it. We do it.
So will you do it from, like, do everything or just the control system?
So we do the input-output solution. We've also got some really good partners that we work with, which are fantastic with motion platforms, with the engineering side.
So you could organise a turnkey
Absolutely.
solution.
We've organised turnkey solutions before, been part of many projects. We even work with companies who are designing and building their own aeroplanes and building simulators for them so that they can train the pilots.
Like light aircraft?
Oh no, we're talking military trainers as well.
Military trainers too?
Yeah.
Fantastic.
So, love to work with an F1 team. That would be awesome, though. Absolutely love to work with an F1 team.
I'll just have to take it for a test drive.
Absolutely. That would be,
down,
prove how crap I am at it, but we'll see how we go.
Awesome. Thanks, Rod.
No worries, Dave.